Okay, so exponents and power. So when we're looking at these, we've got some rules that we can follow that can actually make exponents a lot easier. But what we need to kind of remember, and this is what all of our rules are based around, is expanded form, meaning if we had 2 to the 4, that actually means 2 times 2 times 2 times 2. Now if we evaluate that, we get 16. Okay, that's easy to do. It's easy to think that out. You could put that in your calculator. It's not too big. But if I said like 2 to the 32, well, that gets a little ridiculous and it's hard to put in your calculator. So when we get questions like that, we need to understand how can we simplify these? What are some rules that make these things easier? So I'm not going to go through all of these, but what I do want to show you is that there's some different things that can kind of help us. These two are drastically different. So if I were to write them out, I would have -3 times -3 times -3 times -3. Okay, well, that one's a little bit harder, but that's 81. Now the next one is actually going to be negative and then 3 times 3 times 3 times 3. So that negative's all by itself. We need to do BEDMAS. We need to do exponents first and then that negative. That negative is actually a multiplication. If I put this question something like this, like 16 minus 3 to the 4, then everyone realizes what they have to do. But if I just leave it the way it was and say simplify or expand out, a lot of people get it wrong. So this is -81. Now the next one, we've got 3 negatives, so we know that that's going to be a negative. That's -27. I'm not going to expand these ones out. I'm going to just use my calculator. 3.5 to the exponent 4 would be 150.0625. Now this one, we've talked about this a little bit. This would be 2 to the 4 over 3 to the 4. So I'm just going to write it like that. You wouldn't need that step necessarily, but it does make things a little bit easier. So we're now going to have 16 over 81. And that can't simplify, so we're done. But what about when we have things like this? So we've got product here. 3 to the 2 times 3 to the 4. So if I expand that out, I'm going to use brackets. This is going to be 3 times 3 times 3 times 3 times 3, times 3. Well, that's just really, I could put a times in here and it's not going to change anything because I actually have it there. That's just actually going to be 3 to the 6. Okay, there's 6 of them. Okay, down here, if we were to write this out, we would have 2 times 2, times 2, times 2 times 2 times 2 times 2 times 2 times 2. Okay, this is always going to be an exponent 1. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2 to the 9. Now the same thing here, k times 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 k. Well, that's k to the 8. So the general rule, and I'm going to just write it down here, is if we have a to the exponent m times a to the exponent n, that's going to be equal to a to the m plus n. We're just adding our two exponents. All right, we're going to look at one more rule. We're going to look at quotients. Now this one we have to remember how we can expand, and also that we can write this as a fraction. We can have 3 to the 5 over 3 to the 3. This could be 2 to the 7, oh, that's a bad 7, over 2 to the 1, or k to the 8 over k to the 5. So what we can have here is, if we expand it out, we would have 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. Now the next line, I'm going to write them all out first, and then I'm going to show you the rule. 2 times 2, that's 3, 4, 5, 6, 7 over 2. And then k is the hardest one. I don't know why I picked k as my variable here, but especially writing these time symbols out, it's pretty brutal. But we're almost through it, so we'll just struggle away here. Now, if I look at this, any number that's on the top, I can reduce it on the bottom as well. So all of those become 1s, and we're left with 3 to the 2. Here, I can erase one of them. There's 6 2's on the top, and this would be over 1, so it's just 3 to the 2. This is 2 to the 6. The k's, I can do it the same way. And that's going to be k. Oh, I don't think I wrote enough k's on the top there. 1, 2, 3, 4, 5, 6. There should be one more. There we go. Because that should be k to the 3. Now the general rule here is if we have a to the m divided by a to the n, we're going to have a to the m minus n. We're subtracting the exponents. Has to be a common base, so the base of the exponent has to be the same, but we can subtract the exponents if they're common. Now this one's a little bit different. We can actually subtract up or down. So I'm going to show you one more example. If I had and I'll make it small, if I had 2 to the 2 over 2 to the 4, and we expanded that out, it would be 2 times 2 over 2 times 2 times 2 times 2. Well, remember, these all become 1s. So when I do that, I've got 1 times 1 on the top over 2 squared on the bottom. Okay? So let's look at some examples. Okay, it says simplify and solve if possible. So if we're solving these aren't all that hard, but I'm going to write it as a single exponent first, and a lot of the times the questions will say that. So this is 3 squared and 3 cubed. So I'm adding the exponent first. So we're going to have 3 times 3 times 3 times 3 times 3. But we don't have to write that out anymore. We can write this as 3 to the 5. And then you got to learn how to use your calculator. Okay, you need to get 243. You might eventually memorize that. That's one of those ones that it comes up quite often. Now, what if we have numbers first? Well, let's just look at these numbers. 2 times 3, that's 6. And now they're out of the picture. So we've got x and x. Well, I know I'm going to put an x, and then I add my exponents. 4 plus 3 is 7. Okay, same thing over here. I'm going to write it as a single exponent first, because 12 to the 9 is really big, but 9 minus 7 just gives me 12 squared, and I know 12 squared is 144. All right, this one I purposely made it kind of tough. We're going to work with the numbers first. They don't divide evenly, so we can't divide them, but we can reduce them. They both divide by 4 here. So on the top, I'm going to have 3, and on the bottom, I'm going to have 2. We've reduced this down. We've divided this by 4, and we've divided this by 4. Okay, so those reduce down. Whatever we do to the top, we do to the bottom. Now, I'm just looking for the bigger exponent. So I'm going to look at the a's first. Well, 3 is bigger than 1. 3 minus 1 gives me a squared on the top. For the next one, I'm looking for the bigger exponent out of 5 and 2. Well, 5 is bigger than 2, and that's similar to this example here, meaning that we're going to have the 5 on the bottom. 5 minus 2 is going to leave 3 on the bottom. Okay, we'll talk about this again tomorrow.